Okay, let's go ahead and get going here. So thanks for coming out. I know I'm standing between you guys and like a room of free beer down in the Expo Center. So thanks for walking all the way across here. And if there isn't free beer over there, I'm sorry. I just assumed there was. So my name is Jeff Schertz. I'm the lead Microsoft Solutions Architect for Polycom. I'm a Link, make that a Skype for Business MVP. I have been for a number of years. Pretty much based on just kind of face-to-face conversations with a number of you, people I recognize just from discussions today. I think there's a lot of people in here that already understand video or maybe have some video requirements, whether it's stuff they're just looking at now or things they've been trying to deal with for quite a long time. Also assuming, because this is based on the fact that this is pretty much tech ed and not Link conference, where I've presented in previous sessions, that there might be some people in the room that barely know how to spell Skype. That's probably a stretch, but at least maybe haven't learned some of the things that Skype can do from a video standpoint. So I know this is a 400 level session, but I'm not just going to go into 400 and just bore everybody to death. I'll kind of have a story arc and go through and start with some foundational information, make sure that as I get into some of the more deeper information on some of the interop capabilities that Skype for Business is bringing, that everyone in the room can hopefully follow along in some of that stuff. So a little bit of 100 level, quickly into 300 and 400 level type stuff. So we'll go over what's new in the video experience within Skype for Business. Be pretty short because there's not a lot of new stuff. We'll kind of recap a few other things that I've talked about in the past. Get into, sounds funny to say Skype for Skype interop, but it's linked to Skype interop made a lot more sense a couple months ago. But I'll go into the consumer platform and kind of recap a few things that have been available for some time. And then spend the bulk of the time talking about standards-based video interoperability and some of the capabilities that the product has embedded and some of the things that some of the Microsoft partners can go above and beyond that. So to start out with, I want to make sure that as I jump around, or try not to jump around too much, that people understand some of the foundational concepts as we're looking at traffic flows and media, is that there's two main things. One, there's this concept of signaling, which is kind of the communication to start the communication. But basically, we want to do something, we want to communicate, have a session. How do we make sure we can set that up? How do we first communicate to get to the bulk of what we want to do? And then what that is that payload. Is it voice or video or content or all of the above? But then the media itself. And then what that path may or may not look like. Because some of the times, some of these communication paths are the same. Sometimes they're not. Traditionally, signaling is going to kind of traverse server to server, where media is always going to try to take the shortest path. Second thing is this concept between peer calls. So just two parties. Could be two Link clients. It could be a room and a Link client. But it's just one conversation between two entities. So it doesn't need a lot of flexibility in terms of different things. Because it's, well, I support something, you support something, let's just negotiate and have that. And then there's conferences, which get ultimately a little bit more complicated because there's different entities, and then the path that they send media to, that can, again, try to be short, but it's sort of a spoke and hub model. So I'll come back to these concepts in a few places. So if we take a look at the video experience in Skype for Business, it's pretty much the same as Link 2013. There's a few important things that I've pointed out, or I want to point out, that are related to the conferencing solution. One, it's not like Link 2010 to Link 2013, where we went from an active speaker limitation to 5 video streams. It's different. It's improved upon. Link 2013 to Skype, other than maybe some of the UI elements and the colors, it's the same. So people that are already using the product, when they get that Skype for Business update, whether they wanted it or not a couple weeks ago, they still can utilize that application. It's not completely different. Conversations in the same place. You still can do the same things. Some of the back-end capabilities might be a little bit different, and I'll talk about what those are, but that's kind of hidden from the user. A couple of the things that improve the video experience. One is this preview window that pops up that anyone who's used the client probably really likes. It's difficult to deal with conferences or just calls where you're alt-tabbing between different applications and you maybe forget you're on video because you don't see the video you're looking at, which could be embarrassing. So this keeps that video screen up. That's just something that I found that's very helpful in terms of improving what Link had before. Another piece that, honestly, I don't know why it was never really addressed in Link. It didn't require an entire Skype or a UI refresh to address that. But one of the things I always struggled with in the past was the fact that the mute button was a little bit too much, had a little bit too much going on. It was, whether you clicked it or did a hold on a tablet or a long press, you had to mute or unmute from there, but that's also where you had the devices buried, transfer information, setting the volume, or the thing that always drove me nuts would be you'd be on a long hold, 30 minutes, and that keypad or that client is buried way behind, and you're frantically trying to get to it before they say, press 2 to not be hung up on in 3 seconds. So just these little things have made the conferencing experience a little bit better. But other than that, you're kind of, scratching the bottom of the barrel to come up with a number of slides. So if this was the whole presentation, it would be pretty darn short. It's still Link 2013 on the back end. So that being said, everything that was applicable to 2013 is still applicable to Skype for Business. So we look at how bandwidth is utilized, the video codecs, the priorities that they're selected in, the resolutions they support, the different frame rates, all the multi-stream stuff I'm going to talk about in a few slides. It's all the same. So I certainly don't need to recap what there's already a recorded session that I did at Link Conference last year. I really dive into where these streams can go, how many of these streams can be there, how big the streams can be, how many different ones may fluctuate. All that stuff is still applicable. So it's not like, all right, we're going to upgrade to Skype for Business, and now I have to redo my entire plan in terms of how I'm going to deploy all this. So there's one thing that I did cover in a little bit of detail in that session last year that is important to how one of the interop services works and how you kind of deal with scale of the pools, is this concept of temporal scaling. So in Link 2013, Microsoft moved away from real-time video as the primary video codec in the platform and moved towards H.264 SVC. So scalable video coding, not just this temporal scaling piece, but just SVC in general, is what allowed Link to basically move away from a limited single active speaker experience and go to a gallery approach. So that is partially done by just using SVC, where there's not any sort of transcoding done on the Link AVMCU or the Skype for Business AVMCU. It's just an endpoint encodes video. It sends it either to another endpoint or through a conference server through that AVMCU, and it goes somewhere. Parts of it might get stripped out, and I'll go into that, but it's not where it's sending that stuff all over the place. So SVC has multiple different modes that can support frame rates, different resolutions. The implementation of this codec that Microsoft has used is only so far in Link 2013 and in Skype for Business Server using just that first mode, which is temporal scaling. What that gives you the ability to do is encode up to 2 frame rates in the same stream. So in a peer-to-peer call, this really doesn't mean anything, because the other system is saying, I want a frame rate. I want 15 or 30 or 7.5, but it's not going to ask for multiple frame rates. But in a conference call, that might be something that pops up. So before I show the scenarios of why it might happen, I'll show how Link and Skype for Business actually does this. So the clients have been doing this since Link 2013. The idea is that if it's in a conference call and there's a frame rate supported or requested by another endpoint, it will encode that frame rate. But it always encodes in 2 layers, this base layer and an enhancement layer. And basically, it's just putting every other frame in those layers. So it encodes a frame, base layer, encodes a frame, enhancement layer, and just pops back and forth. But it's done in a way that these layers can easily be stripped apart. So when this stream makes it to the server can decide, this guy wants all of it, so I'll send the whole stream. This guy wants half of that frame rate. So I don't have to tear the session apart and drop every other frame and put it back together. I will just literally just ignore that enhancement layer and send just the base layer to that client. So this puts no additional impact on the encoder itself. So if I have a Link client and I'm sending 30 frames a second, I can support requests for both 30 and 15. So the way that looks is, let's say I'm in an AVMCU call or a Link or a Skype for Business meeting, and there's one endpoint in the call, and it's saying, send me 30 frames per second in video. I'll encode 30, but I'm going to encode it in 2 individual 15-frame layers and package that together. So then we have another system join, and for whatever reason, it only is requesting 15 frames per second. It could be a system that hardware bandwidth, for some reason, it just says 15 is all I can support. It could be based on the number of participants in the call and the size of those squares getting smaller. The low resolutions in SVC actually only support 15 frames a second. So there's a couple different scenarios that this might happen, and this right here we're looking at is pretty common in calls. We've got different devices on different network speeds and different locations, all part of the same call. So me being the encoding endpoint, no impact whatsoever, I'm still sending the same frame, or the same frame rate. So SVC actually supports 3 frame rates. It supports 7.5 frames as well. It's rare, but it can happen. But the implementation of temporal scaling does not allow for 3. It's just 1 enhancement layer, not 2 enhancement layers. So if this scenario comes up where for some reason an endpoint it can't even handle 15, it's going to take 7.5, my machine has to fire up a second stream. So now I'm encoding an entirely different video stream at a different resolution or possibly the same resolution, but at a lower frame rate, and again, in that 2-layer approach. So what could potentially happen in this scenario if we take it one step further is that the system asking for 30 frames drops off. I don't need to continue supplying that 30-frame session because I can do the 7.5 and 15 from the 1. So there's some flexibility in this. This is pretty rare because 7.5 frames almost never happens, but it's in there. It could happen. So I think based on the fact that it's so rare, just having 2 frame rates allows Link to really handle all these different common requests and not put any extra load, whether it's CPU or bandwidth, on the encoder. Because you have to remember that in this scenario, the other endpoints are doing the same thing in the other direction. So if you've got all these systems supplying different frame rates, you can get necessarily a lot of number of streams at the same time. So that's temporal scaling. There's a concept of spatial scaling, which is a mode above. It's defined in not the implementation of SVC, but the documentation and the parameters which within SVC can be written, how it's defined. There's additional modes. Microsoft hasn't used those modes yet, so there's a lot of room for expansion in this protocol, and that's why we don't see a new protocol for video in Skype for Business Server, and we're not going to see changes that quickly. There's a lot of room for growth. So today, because spatial scaling is not being used, when there's requests for different resolutions, the endpoint must deal with the entire payload. So here, we've added a workstation that jumps into the meeting and goes, I want to see the speaker in full screen, so I'll switch to active view, or active speaker view, and get rid of the gallery. At that point, we're showing the video in a much bigger window, and the way Link and Skype for Business work is this is all request-based. It's not, you have to give me HD, it's, I can support high definition, and it would be a better experience for me if you could send it, but my endpoint, the one on the left, could say, like, dude, get lost. There's no way I can encode another frame rate, or I don't have the bandwidth, or I can't do it now, but in a few minutes I might. So that's why in some meetings you could see quality get poor and then quality get better, and it's not necessarily packet loss. It could just be a lower resolution was sent for a little while, and then it was able to basically deal with that request and provide it. So at this point, my workstation, the one on the left, I'm now sending out 2 full video streams. These streams can have that temporal scaling capability, so inside of them is 2 frame rates, but not multiple resolutions. If I get another request for a low resolution, that comes in there as well. So the downside is there's more work on my system, and it's only going to basically take that job if it has the bandwidth to do it. But the upside is that you get a better experience for the entire users. In previous versions of the platform, there was more of this lowest common denominator experience where as these systems that had limited resolution requests come in, the system can only send 1. So then now you're getting 180p on all of them. And you can imagine 180p is not going to look anywhere near high definition in full screen. So people would go full screen and say, wow, Link sucks, the video's bad, and they go back down. So you don't see that stuff because on the back end, these requests are being handled and scaled up and down. So this will all make sense. Well, hopefully it makes sense now, but this will apply to the interop capabilities I'll talk about in a little bit in terms of how you can scale and size those environments. So I kind of joked about this earlier. So Skype interoperability. That's kind of like, doesn't make a lot of sense. But we're talking about Skype for Business, which everybody in this room probably should know that it was Link. It's the same core infrastructure. It's that same code, just improved upon and rebadged as Link or Skype for Business. So back in December, Microsoft released the ability to finally do video calls between Link clients and Skype for desktop Windows clients. So it was released in December as a functional thing, but even 2 years back, they've already started to put some of the groundwork in for that. So where we're at today now is that with the reskinning of the Link client as Skype for Business, we've got and if I just kind of cut all the peripheral stuff out and look at just the video tile, there's almost no difference in these. So this is those initial steps towards having a very seamless experience, whether I'm on my business computer using my Skype for Business client or I'm on a home PC using Skype to talk to family members. It's bringing that all together. The one difference you may notice is there's 4 buttons on one. That's how you can share content, which that content sharing capability is not something that's embedded into the consumer client yet. That's something that's part of the enterprise client. But this is a live call that I did between 2 PCs in my own home office. So what happened in December was Microsoft pretty much put the last nail in the coffin of the old kind of V1 approach. So there's been Skype and Link interoperability for quite some time. You've been able to do IM conversations for a long time, basically since that became Skype and replaced the Windows Live and Windows Messenger products. And audio was added a couple years ago, but the way audio was done, it was transcoded on the back end. So Microsoft had a whole bunch of mediation servers in their Skype cloud, and they were transcoding audio calls back and forth. So they were basically dealing with the media for that. So not necessarily scalable up to a large amount. So in this version 2 gateway, or this version 2 architecture, what they did is they updated the Skype gateway to look just like a Link client, to speak like a Link client. And in the meantime, previously, they had already started to put some of the capabilities of the different platforms in each other. So the Skype consumer client, when Microsoft purchased it, they got the Silk audio band, or the audio codec. They've done a number of tests, and there's some sessions from Link Conference last year that went into details on this. But basically, in head-to-head battles, Silk beat up on RTA, or real-time audio, all day long. So over the last couple of years, we've seen cumulative updates to the Link platform not only insert Silk, both wideband and narrowband, as an option for audio codecs, but slowly start to march up the list of priority and be used in more calls. Not just a Link to Skype audio call in terms of Link to Skype consumer, but even if you take 2 Link mobility clients on your Link 2013 platform today and call each other, they'll use Silk for audio. They're not going to use real-time audio or G722 or one of those other codecs. So those pieces were baked in there. The video codec that Skype Consumer uses is not this SVC protocol that I talked about that has many years of life ahead of it. So Microsoft took that video codec and put it into the Skype Consumer client. So took the audio from here and the video from here and made sure they both had both. So at this point, when they finally can negotiate calls, they have audio and video in common. So the next thing was to say, okay, let's connect these things in a gateway so that they can talk as they're one of the same. And then the last piece for that was to import the ability to traverse firewalls and do these calls over the internet, because that's what needs to be done for this to be applicable, and utilize those ICE stun and turn capabilities to do direct media. And this is the exact implementation that Link has and OCS had and Skype for Business has. So the idea is that when you want to place a call between, like when I took my Skype for Business client registered to my company's on-premises environment, and I wanted to call my Skype consumer client sitting on my Surface in my same home office, the signaling is there's that signaling path. It's all going from server to server, through edge servers, through gateways, and then the call starts to get set up. When the media needs to connect, which could be audio, video, or both, just like any Link client, like any of the sessions you may have attended in the past where how does this connection stood up, it will try all of the different capabilities, shortest path first. So in my scenario at home, they're both on my internal network. They're both 192.168.0 something. So they realize that they can connect to each other. They're not filtered by a firewall or blocked by any address translation. So even though in the previous model, audio would always have to go through the signaling path because there's a server that's transcoding that, We can talk directly between these two disparate clients, and we have a video and audio codec in common. If those systems are not in the same network, like one's in a corporate office and one's somebody at home, there's a couple options for that. First is stun, where basically the edge server and the Skype gateway can be utilized to negotiate that call, but they don't actually have to tunnel the media. The media can punch a hole through a firewall. This is common in home router or home firewalls, not so common in enterprise class firewalls. So stun is tried next. If that fails, then the edge server will say, okay, I gotta deal with the media because I can talk to this side and I can also talk to this side. So this is the exact same call pattern as if I had just a link internal and a link external or federated or what have you. So the Skype consumer client is walking and talking like a link client. If we take a look at what that call pattern actually looks like, here's an example of a SIP trace. This is very similar if I was just calling another link client. You know, we've got the SIP invite, and we've got the trying and ringing and session progress. And then eventually I get tired of staring at myself in video and I hang up on one of the two and I get a bye message, and that completes the call. So if we take a look at those messages individually, the first thing is that from my Link or Skype for Business enterprise client, I send that invitation out. I don't necessarily know who I'm talking to. I just blast out an invite, and it's just got kind of all my default settings on it, including different versions of ICE, because I don't know who on the other end is going to try to answer. I mean, I know who I'm calling. I just don't know what endpoint they're on. I don't know if they're on a Link client or an OCS client or some third-party system. So I just say, here's everything I got. Almost immediately, I'll get a response. This is a SIP trying message that says, okay, I'm trying to do this. And this is my server, like my next hop saying, I've got your message, I'm trying to do stuff with it, just hold tight. This is where you'll hear the actual Link or now Skype for Business, all the new sounds. You'll hear that non-traditional ringtone. The next thing is we'll get a ringing message that comes back in. That's from the far end server. So now we've made the journey from my Link server to the Skype gateway. What's interesting is other than it actually having Link Skype gateway in the name, we can see 2 indicating this is the second version. This is where the messages coming back start to look like a Link message. Now, what's interesting is the ringing is still the same noise, it's still that same Skype tone. If this was a PSTN call, if I was tracing a call from Link or Skype for Business out to the PSTN, the first trying I would have the application noise. On a 180 ringing, it actually is going to switch back to a regular dial back tone, just like regular, oh, I'm calling G711, I'm calling a PSTN number. But this is like a link-to-link call, so that never happens, or it shouldn't happen. If you hear it, it's because you're calling a Link client that might have simul ring turned on too. So they're simul ringing to or forwarding to their cell phone or some other PSTN number. So the next message we get is this 183 session progress. This is the first message back that's actually from the endpoint. So this is the Skype consumer client routed through this pool server and a mediation server we can see, but it's on behalf of that client saying, okay, here's what I can do. So inside of this, there's going to be some session description protocol information or SDP where it says, here's what I can support. And then we get an okay, and then the media starts to be stood up. After this, you're going to see provisional response acknowledgments. You're going to see more acknowledgments, more trying, more okay, because there could be stuff like candidate promotion going on. And then eventually, like I said, someone's going to hang up the call, and then there'll be a bye message. So that pattern is really easy to troubleshoot if you're looking at, well, I'm trying to troubleshoot calls between my Skype for Business client and my Skype consumer client. The whole call pattern underneath looks pretty much like link to link. So if you're already a pro on this stuff, it's really no difference. If we take a look at those initial messages inside the SDP, this is messages inside SIP that says, okay, here's what I support, here's what you can send me. I don't necessarily say what I can send you, I just say, here's what I can receive, and you tell me what you can receive, and we'll compare the list together. So I said that first invitation, I don't really know who I'm talking to, so I'm just assuming I'm talking to someone as part of the Link world, or the Skype for Business world, and I send that out. So we can see a long list of audio codecs and a couple video codecs. The ones in blue I've highlighted because those are the only ones that are in common with the system on that first initial session progress. So this consumer client's like, all right, I'm not really sure I'm talking to either, but here's my initial message, here's what I support. There are some things in common, but notice that Silk is not one of them. G722 is the highest audio codec on that list, so it's
not necessarily ideal. Notice that the video codecs are there, so we're already doing some of the link stuff. I talked about initial tries and initial buys. There'll be more messages coming up where, again, there'll be a new session progress that comes in, and then I send an invite out matching that. So if you take a look, there's two big changes. The first is that the IP addresses went from public IPs to private, because my two systems in this call were in the same network. So at this point, they've already done checks and realized, hey, we can talk directly to each other. And the other thing is now they're like, oh, you're Link or you're Skype for Business. I get it, so I am too. And then it updates the order of the codecs that the support model shows. So now they both prefer Silk. It's all the way up at the top. And then SVC is the only common protocol. So that's why you can only do Link 2013 and up video calls with Skype Consumer, because the consumer Skype desktop Windows client doesn't support real-time video. So let's transition into standards-based video interoperability. So this is an interesting thing, because as you look at a lot of the documentation, and I'll cover some of the terms, a lot of this is thought about as like, okay, how do we take old junk and make it work with Link? But some people might have some old stuff, but that's not traditionally what a standards-based traditional video system is. There's systems down on the expo floor today which use cutting-edge technology, still using those standards-based solutions, but we need some way to bring those together in with Link. Because as Link is growing from the desktop into the medium-sized boardrooms and growing, you're seeing the Surface Hub and other applications like the Roundtable 100. But there's still a need for fully immersive rooms, all sorts of AV integrated rooms. So whether they're old or new, you want that investment to come together and have Link be the driver and be the desktop solution for all of that, but still bring everything together in one conference call that everyone can be part of. So if you look through a lot of the documentation, Microsoft uses this term of VTC, which is just a generic video teleconferencing system. So what it is what I was just talking about. Standards-based systems, they could be old, they could be something that just rolled off the factory yesterday, but things that don't inherently speak the Microsoft languages. Different monitor configurations, different audio configurations. I mean, this room could be equipped with that, with ceiling microphones and a whole AV solution. What it is not is Link Room System, the Skype Room System, Roundtable 100. Those are native Link systems, so there's no interoperability model that's applicable to those because they're already natively integrated. But then you're still within that certain island. So what if you want to have Link Room Systems and telepresence systems? So you still need a way to join these two together. So this is a slide that I covered in the first Link conference, and I kind of want to recap it quickly. When Link 2013 was first announced, one of the things Microsoft talked about is like, okay, we're moving away from real-time video as our primary codec. We're still going to support it for legacy and interoperability with our own previous releases, but this is a standards-based video codec. And then people started deploying Link 2013, and we're like, well, why can't my video systems that are standards-based work with Link? Well, there's a number of reasons for that. One, only the media payload, only that video codec is standards-based, that H.264 advanced video coding. So when you pull all the layers away, there's some commonality at the bottom, but you can't get to that right off the bat. So there's this concept of like, well, SIP. There's different versions of SIP. There's standards-based SIP. There's Microsoft had taken the standard of SIP and implemented a number of extensions into it that bring OCS and Link and Skype for Business experience. So these extensions change the dialect. It's like two different languages that were originally based on Latin, but if you speak French and you speak English, you're not going to have a great conversation between the two of you. There might be 1 out of 10 words might actually sound familiar. So there's that initial piece where signaling just isn't the same. And then we get down into the session description protocol, and it's like, well, we don't even have any codecs in common. There's no audio and video codecs. So even if we could tell each other what we do have in common, we don't have anything in common, because it's not exactly the same implementation. So what the interoperability model is to gateway or translate and bridge the gap with that to the point where you get down to, okay, now the media codec, the video, is based on sort of the same engine, so I don't have to put another decoder in this solution to decode and re-encode it. It's like I've unlocked all these other layers, and then some of the heavy work. Like this other stuff is just the discussion, it's messages. It's like, okay, I understand that example and I can do this. But when you get to the media, it's like, whoa, I got to spend some CPU power to tear this down and put it back into a different language. So if you don't have to do that, that's a good initial step into improving the experience. So the first interoperability model we'll talk about is actually not an interoperability model. It's just native integration. So it's that either link room system or the Roundtable 100 or a third-party VTC that has link capabilities built into it. And you can see some systems like that down on the expo floor where they don't need interoperability solution. They have it embedded. They can talk Microsoft SIP. They have video codecs in common. The RTP and RTCP streams can be the same. So again, short presentation if that's where we're going to end, because there's nothing to solve, and I don't really have a very exciting job at that point. If we look at these true interoperability models of like, okay, we have systems that don't have any link integration capabilities, what options are there out there to bring these together? So the traditional model has been basically use a gateway. We see the same things happen on the audio side. Video is just that much more complicated because video is a little bit different than audio and it's a lot heavier. It's just more stuff to move. So there's been third-party solutions out there for quite a while. This model from the third-party side is sort of being moved away from because there's always been inherent limitations in terms of scale and capabilities. But this is also what Microsoft is baking in from a software standpoint directly in, or not baking, but has. So this is in the Skype for Business server code. So I'll go through all of that for the last half of this session. So while it's a gateway mode, it's a native gateway component. It's not a third-party piece. It's just another role in the server deployment. Another model is basically having an external MCU or multi-point control unit. So another bridge. You've got a bridge inside of Link where all the Link conversations for a conference can happen. And then you've got a third-party system. The Link one only can talk to Link clients and Link codecs and protocols. The standards-based third-party one has a lot more, including even the Link ones as part of that. So traditionally it's been like, well, how do we have a meeting with all of these systems? Okay, we got to all bring them to the place that can speak the most languages. So on the back end, that does function. You can get audio and video and sometimes even some level of content sharing. But it's not the native user experience for Link users or Skype for Business users. The calendaring might be different, might be out of band. The signaling while staying in the Link environment, their media is negotiating directly to this other system. So they won't get gallery. They'll get what people call Hollywood Squares or Brady Bunch, the continuous presence layouts in an active speaker peer call. So it's a step in the right direction, but it was never that native piece. So what third parties have moved towards now, and also when you're doing that, you're also wasting one of your bridges. You've got your Link environment you deployed, your Skype for Business server environment you deployed and sized for all these meetings, and now you're just not even using it. It's still used to translate the messages and move them around IM, but you're not actually using the conferencing components of that. You might be using it for ad hoc calls, but it's not consistent, it's hard to scale. So what things that have been moving towards is this idea of using both bridges together and cascading this stuff. So native signaling on one side, native signaling on the other side, native codecs on either side, and we keep this delineation down the middle of, we don't introduce problems by having people have to come all the way over from one side to the other. And all we do is we just shuffle audio and video and content streams between them. So these are fully featured experiences that with Link 2013, with Skype for Business server, you can interoperate a lot of those components. So again, you can see things like this down on the expo floor on display showing audio, video, content. So what about not using a third party? What capabilities does Skype for Business server have today? And that is this new server role called Video Interop Server. So Microsoft talked about this in the first Link conference. They demoed it in the second Link conference in Vegas last year. And now it's released. It's part of the Skype for Business server on-premises server deployment. So this isn't something that's part of any of the cloud offering features that they've been talking about the last couple of days, but this is, you deploy Skype for Business server on premises, and you can utilize this. So what is it? It's a gateway. It's an intermediary between the Skype for Business server world and some video teleconferencing systems. What can it provide? Well, here we go. We look at, it can do peer calls and conference calls. There's already some older third-party systems that integrate in only one of the other ways. Like they can maybe do peer calls but not provide conference calls. So this is, peer calls are okay, but the model of everyone just using scheduled meetings and not like I got to find a room and see if it's available and call it and hope someone's in there to answer the call. And then I called the wrong room and the present's red. Does that mean there's someone in the room? And I could go on forever. It just confuses the heck out of users. It's more of just meet. Just everybody lives out of that join Skype meeting approach, all coming out of Outlook. So supporting conference calls is really the big benefit for that application. So what does Viz not provide? It doesn't provide presence because it's not that traditional gateway model of we're registering a room on behalf and giving it a entity with presence and something I can call or it can call me. It's just bridging this session through. It only provides audio and video. There's no content sharing capability with that. Content sharing can work in one direction where some room systems will actually send the content as the video instead. So if you have a traditional room system and it's talking to a system which ends up being Link, it knows like, hey, this guy he doesn't support video and content streams concurrently because it's a legacy type system. So when someone activates content, the old I'll go in the conference room and plug in the VGA cable to my laptop and then push a button on a thing and now content's up on the VTC screen. That can end up in the Link side, but it'll end up in the video, and then you lose the room video because it's stealing the video session. And then there's no way to send content from Link back. If I'm a Link user on the other end and I click Share Desktop, the people in that conference room, they're never going to see that. Also, Viz can only be used to connect these VTCs to your on-premises environment, so your meetings, your users' scheduled meetings. Those meetings live on your pool, and that's where everybody goes. You can have federated people in that meeting. You can have federated Link users, Skype for Business users, but you can't have a federated VTC, or you can't have your VTC go to someone else's meeting via federation. So Link can traverse the whole solution. The VTC can only get in that conference that's right there in the same environment. And also the VTC can't be external. So Viz supports Edge, and I'll get into that call flow in a bit, but it supports Edge for the Link half of the conversation. So Link can still be external and utilize Viz to see a VTC that's in the call, peer-to-peer conference. But the VTC can't be off-site and utilize Edge because it doesn't know how to talk to the Edge server. It can't talk directly to it. It doesn't support ICE done in turn as implemented by Microsoft. Another thing is Viz doesn't support RTV. It's only SVC and up. So that means only 2013 and higher clients are going to see that conference room. Or when they speak, that conference room will only see their video. If there's a 2010 client or some interesting capabilities with calls with mobile clients, which I'll go into, then there's some video in neither direction, or there's some scenarios where one person can see but the room can't be seen. But basically, anytime you get away from an all SVC conference call, there's some gaps in the capability there. You also can't, because the VTC is not registered, there's no presence, you can't go drag and drop it into a meeting. In fact, you can't even reach out to them. The way that the VTCs make calls to Link or join a conference call is they have to call in through sort of a telephony pattern. You can't from Link go, I want that room, I want to call him and ring it, or drag that room into another thing. Also, there's no PSTN calling capability with that, so you can't call a PSTN number from a VTC or have a PSTN phone call a number and have it ring to the VTC. Another thing is that basically it's a certain topology of VTCs and it's SIP only, so it doesn't open the door for what I talked about earlier with third-party solutions that can support all these different protocols. Also, it's active speaker only, so the VTC is going to see one video stream. It's whomever the Link or the Skype for Business server says is the active speaker, and it's going to send that session. It's not something where you're going to get a continuous presence layout that Hollywood Squares, Brady Bunch. So how does Viz work? The way I kind of explain it to people, especially if they're already familiar with Link, is that if you know how the mediation servers work and how audio works in Link, where you've got a user and they register to a pool, and then there's a mediation server, and then a media gateway, and then the PSTN with a phone on it. This is basically the same exact thing, but for voice and video. So Viz is like a mediation server or a mediation pool for voice and video. Now, you might be asking, why not just this? Why couldn't we just do this in the first place? The entire audio capabilities within, even from OCS days, whether it's using co-located media pool or media bypass or any trunks or any of that stuff, if we go back to the SDP that I was talking about earlier, I didn't point it out, but there was M equals audio and M equals video in SDP that says, here's my audio stuff, what I can support, forward error correction, whatever. Here's my video stuff. The M equals video, all of that is just chopped out of the messages. So if anyone's ever had a SIP trunk between Link and Call Manager, and they've got those Cisco phones that have the video on them, and they call, I'm like, why does the video not work? Well, the video doesn't work because all the video information is just completely truncated. It's not part. This is an audio-only solution. So Viz is that solution for audio and video. So what Viz does is it transcodes video. So I've been talking about transcoding different protocols. This is a very light transcoding job because they're almost the same. We've got this H.264 SVC implementation that Microsoft has specific to Link in 2013 and Skype for Business Server. And if we tear all those layers away I talked about earlier, at the bottom we pretty much have the basic components of an H.264 AVC package. So it's still transcoding, still decoding and re-encoding, but it's not even apples to oranges. It's like two different types of apples. So here's why I spent 10 minutes talking about temporal scaling before. So one of the capabilities of Viz is to also improve the user experience and not have this, okay, we have a gateway, but we're stuck with this lowest common denominator junk. Like somebody comes in the call and can only support a low resolution, and now everybody gets that low resolution. And now we're looking at video on a large screen, and it looks terrible. It's all blocky and looks like max headroom. Viz isn't good the experience isn't that good if that's what you're providing. So one of the capabilities Viz has is to upscale or downscale that. So either improve the experience and make it better, or don't blast the network or the clients with a bunch of bandwidth that they don't need because they're just going to try to throw it out anyway, or it's a resolution they can't support. So if we take a look at this call where a VTC calls into a conference call, that first stream, number one, it negotiates an HD session, right? Let's say it's 720p. And the first workstation is asking for that because it's going full screen. So at this point, we've got a nice high definition full screen video from the room being provided to the Skype for Business client. The second participant comes in, they stay in gallery view, and now I've got these little squares, so they only need 360p. That's all they're asking for. Without this capability, the Skype for Business server would say, well, I can send 720p to him, but not to you, but I can send 360p to both of you. So the first workstation would get low resolution in that same full screen. It wouldn't be ideal. And then so on. So as you get lower and lower requests, it can transcode additional streams. So this is important when we look at sizing because this is one VTC joining one call, and we're now running 3 transcoded sessions, chewing up processing power in the Viz server for that. So this is something you can control. You can turn this on or off. So what can use Viz? What can leverage it? So I talk about Viz, it's a pool. So this is not a pool that can be co-located on the front end like an audio mediation server. Because of that video work it has to do, Microsoft doesn't want that impacting the user experience by hammering your front end servers and making everyone's IM take 10 minutes with a little spinny wheel. So you can move that off to a separate pool and manage that for just the video transcoding component. The media will go between endpoints and servers, and they'll hit Viz. So the VTC can't send its media directly to a Link client or a Skype for Business client, and that's covered why that is a little bit earlier. They've got to go through the Viz component. So what models of video gateway? Let me back up one. So the video gateway, I didn't talk about that much, but basically this is kind of like where you think of a media gateway for audio. This is a gateway for video. So what could that gateway be? Well, right now, in terms of what's currently supported, you can go look at the Viz components that are in the new TechNet documentation for Skype for Business Server. This is what Microsoft officially has supported and tested. So the video gateway needs to be CUCM release 10.5 or newer, and that's the gateway that Viz can trunk to. And then the VTCs that have to be registered via SIP, not H323 or any other standards-based protocol, they register to CUCM, and it could be any of these models that they've tested of different Cisco telepresence systems, and they need to be on the TC7 or newer version of firmware on those endpoints. So I'm curious, raise your hand if you have all of this in your environment. So that's pretty good, like 10, 15, 20? Okay. So not everyone raised their hand, right? It's targeted, and this is at launch, so this is at RTM. There'll be more capabilities that Microsoft will talk about potentially in cumulative updates later on expanding upon what the tested and supported solutions are. But as of today, this is what you can use Viz for. And I've been in calls with Microsoft where I've seen them join calls from a using Viz on the back end. So what does Viz look like in Skype for Business Server? It looks like a front-end pool or a mediation server pool. It's just another pool. It can be installed as a standalone server. So same kind of a premise where the FQDN of the pool and the FQDN of the server are the same thing, just like a standard edition server. Or it can be done as multiple servers in a pool. Same approach of I create and define a FQDN for my pool. The server has its own unique FQDN. The pool FQDN can have or leverage DNS load balancing, multiple IP addresses. And if you look at the TechNet guidance, they basically say one server in the pool can handle about 16 transcoded sessions. So if we go back to that slide a few back, if we're populating and transcoding different or multiple streams, one system is already using 3 of potentially 16. So based on your scale, you may have to deploy a large number of servers or even multiple pools. Now, where does that 16 come from? Because that's kind of an arbitrary number. What the documentation covers is that if you build a Viz server using the same hardware requirements or parameters that they have in for the front-end servers, that's where that sizing comes from. So if you double the numbers, then you probably could do 32. If you slash it in half, then you hit 7, 8 sessions, and you might see the server start to, weaken at the knees. So it's just based on, it's not like a traditional resource thing where you have 18 ports, and when you get to the 18th port, you're done. It's just, well, it's going to try to transcode another session, but now the processor's spiking and memory's running out. So in terms of resiliency, there's resiliency both at the Viz pool and at the front-end pool layer. So for Viz, you can have multiple pools, multiple trunks. You can do a mesh, and I'll go over a couple of those different topologies. So that way you're kind of protected whether it's connections to the video gateway or connections coming in. Front-end failover uses the same model that Link has always used. I wouldn't say always, but traditionally used, and that Skype for Business still uses, where when you define a front-end pool, you pick, as long as you have a second pool, you pick an associated backup pool. So you can set that primary backup pool relationship, and then other clients and servers will leverage that to know, hey, if my primary pool is down, this is the other pool I'll try to connect to for the stuff I need. Viz does the same thing. So Viz is always paired to, which is its front end. So there's nothing different there. If this is already configured when you introduce Viz into your environment, you're already covered for pool failover. And there's some stuff in TechNet that talks about, if it's 5 minutes of consecutive failures, then it'll say, I'm going to flip back over and then kind of do a heartbeat check and go, all right, the original pool's back online. I'm going to start using that as my primary. And you can fail over Viz manually if you need to do any sort of maintenance, just like you would do on other pools. So one of the failover options is let's do multiple video gateways to a single Viz pool. So let's say there's 2 CUCM gateways, whether they're redundant gateways in the same environment or maybe 2 entirely different call manager or CUCM environments that might route to different registered VTCs. This is really easy to do in Topology Builder, same way you would set up multiple trunks from a mediation server to different, like one could be Avaya and one could be Call Manager. You just go and define them in Topology Builder. I have some examples here in PowerShell of some of the new commands that show, well, this isn't the new command yet, but some of the new services, the video gateway identity. So you can see I've got 2 different unique FQDNs for Call Manager or CUCM, and then I'm just pointing the same Viz pool to both. So Viz has 2 routes to go in case one of them doesn't work. Real straightforward. If you want to do the opposite, where you've just got one video gateway, one CUCM environment, but you want pool redundancy, so you have 2 Viz pools, In Topology Builder, you can't do that normally. And anyone who's tried to do some of the stuff in audio, in the audio world in Link previously, should be familiar with the fact that you can't have non-unique FQDNs in Topology Builder. So if you've already got an FQDN and you set it, like here's my thing I'm going to, and I set it, and you go in to create another one, you type the same name, you get that big red box with the star that says like, this name is not unique in the topology. So you basically have to trick Link or trick Skype for Business and say, all right, I'm really going to tell you I'm setting up 2 trunks to 2 completely different things because I've given them 2 unique names, but then just go give them the same IP address. Because it's just Topology Builder doing an FQDN check. It's not actually fact-checking your work to say, hey, wait, these are the same IP. You're messing with me. So architecturally, it looks like you actually have 2 trunks to 2 different environments, but you're just tricking it to have 2 SIP trunks to the same IP address. So then you can use a mixture of the previous slide and this one to set up like a full mesh of, okay, I've got redundant trunks, I've got redundant gateways, I've got redundant viz pools. And realize that today, because I mentioned earlier, the call path is only from the VTC to viz. I have to go to the room and call in and join a call. I can't receive a call from Link. So we're not going to see invitation messages flowing out of Skype for Business into the other side. So link server coexistence. So one of the things is that in order to utilize Viz, you have to have Skype for Business server. You have to publish, or you have to upgrade the forest schema, do a server installation, and then a front-end server installation, and then you can deploy Viz. But it's not required that Viz can only, or easier way to say this is, it doesn't mean your users have to go to the Skype for Business pool. So Viz can bring you peer-to-peer calling to Link users or calling into Link meetings that are running on a Link front-end server, but it can't work with the front-end server alone. Viz needs a Skype for Business server defined as its next hop for signaling. That's what it has to talk to. But once it realizes, oh, I'm talking to a Link client that's a user on another pool, or I'm talking to a conference call that's running on that pool, I can send the media over there and I can do that. So you can't just take your Link environment, install Viz, and start doing this. You got to get that Skype for Business pool set up first. And then also, I talked about SVC and RTV. So all the clients that support SVC video are the ones that are supported clients from Link 2013 up. There's a note on here about CU5 hotfix 9 for Link Server 2013. I believe that's coming out this week. It might already be out. I haven't had a chance to really look at Twitter or anything lately. That's recommended to run, if you want to have this coexistence environment, it's recommended to make sure you have at least that hotfix on your Link front-end server, so that way all of the Viz stuff works well. But the clients, they can be RTM clients. I think the 2013 desktop client, it's recommended to be on the latest CU because there's some improvements to this capability, but the calls would still work. I'm not really clear on what those improvements are. So I hinted earlier about this kind of weird scenario where mobile clients might get a different experience. So if we take a look at a call in place where we've got a conference call running on the Skype for Business front-end server, we've got Skype clients, we've got, which are still Link mobility clients. I think in one of the sessions today or yesterday, Microsoft talked about the Skype mobile clients will be coming out later this year. So today, whether it's this client or tomorrow, whether it's that client, the mobile clients don't do the same thing I was talking about before in terms of multiple resolutions. And it's mainly because a mobile client, you're lucky to get one good video stream out of that. It's probably on a 4G network or a poor wireless. So in these scenarios where there's mixed meetings and real-time video is part of the call, because maybe there's one Link 2010 user that comes into the meeting, and now the front-end server says, okay, all you Link clients and Skype for Business clients, you need to start sending RTV in addition to SVC, so this guy can see you, and I'll send you, and that way you don't have people that don't see each other in the same call. Desktops can do that. They can send 2, 3 streams. The mobile clients cannot. They have to basically downgrade themselves. So if we take a look at this call where everybody's SVC, everybody can see each other, because if the mobile client's speaking, its SVC stream is translated or transcoded into ABC, VTC sees it, and vice versa. Let's say I'm still on Link 2010 for whatever reason. I join the call. Now the server says, okay, all the other Skype clients and Link clients, when you're talking, so only the active speaker, because remember Link 2010 doesn't have gallery, so there's no multiple stream need. When you're talking, fire up an RTV stream. When you're done talking, You just go back, and then your SVC stream shows up on all those gallery views. The 2010 desktop client can handle that. The mobile client can't send an SVC stream for those guys and an RTV stream for those guys, so it just sends RTV only. So now the mobile client's video cannot be seen in the VTC, in the conference room, because that RTV does not get sent to Viz, because Viz can't do anything with it. Now, the mobile client still could see the room, because when the room comes back in, it can receive a single stream. And the AVMC will be like, well, this guy's an SVC, he's talking. Oh, wait, the 2010 client's talking. Here's 2010, here's RTV. So it can get a little bit confusing, but it's good to be aware of these as you're deploying it, because you don't want to be troubleshooting like, why can this guy not see this guy when there's nothing to troubleshoot? It's a limitation of the architecture, and hopefully I saved somebody at least one long evening. So what does Viz look like? How do you deploy it? I mentioned it's a pool, so it's real easy. Fire up Topology Builder, you go and create a new pool, and in this example I'm showing a single edition pool, but you can do multiple servers, so you create a pool name. You select the next hop server, which is, this has to be a Skype for Business front-end server. If you try to make it a link server, Viz isn't going to work. And if there is an edge server there, you assign what that edge server is. And like I said before, that's for, if we go back a couple slides, think of the mobile client as maybe a remote client, and it's actually using Edge to get into this call. Well, its media could go from the Edge server directly to the video interop server or whatever. I mean, it basically can still use iced unturned for that. We can't have any of that on the other side where we go from the green to blue dashed lines. There's no there's no ice done or turn. There's no network traversal capabilities for that. So you define a new pool, but before you publish the topology, there's a few other steps. So one of the things is when you create this, and this delineation is between what Viz was intended to do and what Microsoft currently supports with it. So the first thing that might be a gotcha is that it doesn't even enable TCP. By default, only TLS is enabled, but currently only TCP is supported with Call Manager or with CUCM. So to get the currently supported platform to work, you have to go back in and make sure you turn on TCP. So then you create a video gateway, which is like creating a media gateway in the audio world, same sort of thing. Skype for Business Topology Builder will kind of do that same thing. We'll start throwing ports in like 5067, 5068. Well, that's not the port that typically would be used on the gateway. So if it's TCP, 5060 is the default port for those. So make sure you set 5060 as the port. Make sure it's set to TCP. And then select the Viz pool that you see or that you want to associate with. It could be a second or a third pool. When you do that, you're going to see not only the gateway get created, but you'll see the video trunk be created as well. It's automatically, those two components are created out of the same wizard. So then you go to deploy the server. So you fire up a VM or deploy a piece of hardware. We could talk later about the logistics of video transcoding. Is that something that's good for virtual system, or should you just give it the whole cores and just go, get rid of that virtualization layer? But fire up the prerequisites. This thing's not running IIS, so you don't have 3,700 prerequisites like you do for a front end. You just have .NET 3.5 core. So drop that in there. Run the deployment wizard. And because the topology is published, it knows, oh, this is the name of the server, so it installs the local configuration store, the server components, and you need to put a certificate on it. Now, I just got done saying we only support TCP, so why the heck am I putting a certificate on this? It's still a link server. It's still a Skype for Business server. It's still TLS and MTLS on that side. So it's still encrypted signaling and encrypted media from Viz to pools and servers and clients on the link side, but everything that goes out the other end to Call Manager or CUCM is TCP only. And one of the things that's important to understand is we go back to the signaling and media. You can encrypt media and you can encrypt signaling. So TCP unencrypted, TLS encrypted signaling, and then RTP unencrypted media, SRTP secure encrypted media. You can encrypt both, or you can encrypt neither. And the only other option is you can encrypt signaling and not encrypt media for whatever reason you might want. You can't encrypt media with unencrypted signaling. It doesn't work that way. So you always have to encrypt the signaling before you even have the option to encrypt the media. And that's just how Link works. So it's not something specific to Viz. So the point of that is because TCP is the only supported connectivity right now, if you can encrypt or if you cannot encrypt the signaling, there's no option to encrypt the media. So everything leaving Viz heading towards the VTC, all of that's unencrypted on the wire. And then we fire up the services on the server after it's installed. The first two services are the one that show up on any link or Skype for Business server for the logging service agent and the database replication. And then the third one is video server, real easy, real basic. So fire that thing up. And then there's some default configuration. I touched on a couple of these earlier. So just like there's no ice done turn or anything or encryption supported from Viz over to the VTCs, there's also no forward error correction. Cisco does have a video forward error correction capability. Again, something that's there, and you can see the fact that there's a Cisco parameter in that setting that is an option that Microsoft probably plans to move towards that, but currently it's not supported. So forward error correction can be available on this side, but again, not this side. If and when forward error correction is supported, realize that that could up to double or add up to 50% of the bandwidth going that direction in a really bad network where it's literally sending and firing up and sending 2 of every packet. So the two parameters at the bottom, the sending low resolution and enhanced video experience, the enhanced video experience parameter, that's what enables, and it's true by default, that ability to encode multiple streams where, okay, I've got high def and medium and low definition. If you set that to false, then you're just going to get 1 stream per VTC, which means you can do more conference calls or more conference room calls into peer or conference calls concurrently because it's just a 1-to-1. If you fire that thing up, it could be a 1-to-3 or a 1-to-2, and you just have less scale on that. The support low resolution, that has to do with VTC could have a resolution request from Link that's lower than what it could even provide. Because Link can go all the way down to like 180p, and you want to get away from these kind of lower common denominator scenarios. So what happens is that there's an option to say, okay, if the VTC is sending us something that's not necessarily ideal, let's transcode that one session and bring a better session, not multiples, but just fix the one to the one client that works. So the last part of the configuration is you need to define a trunk. Set that trunk up. You can set some of the parameters in the last slide if you want to change them. Not much you can change because you can't turn TLS or any of that stuff on yet. And then you set up a dial plan. So how does this actually work? Like, how does a user use the system to call? So it's based on basically IVRs and numbers. So what happens is that the VTC, if it wants to dial another Link or Skype for Business user, it calls their number, because this is sort of like routing audio calls, right? So call their number. I mean, they can't call a PSTN number, but they can call the tele URI for that user. Call comes into Viz, brings the client, and then we set up media. So there needs to be a dial plan set up to say, I can accept calls coming in from the video gateway, and Viz is able to find the right thing. If from the VTC you're trying to join a conference call, what will happen is that I need to dial the dial-in conferencing number and then enter the conference ID. So that way it gets routed to the AVMCU, can be part of that call. And then the last setups, which Microsoft has some examples set up and defined in TechNet, is how do you set up the CUCM environment for the trunk, so the other half of the trunk, which I'm not going to go into, and then how do you configure the VTC, because it's got to register to CUCM. So after all that's done, you've got the ability to take these specific Cisco systems against CUCM and have them register directly and call, or not register, but call directly into the Skype for Business environment. So where that leaves us is basically, I went over a bunch of different interoperability models. Obviously spent a lot of time on Viz because it's brand new and there's not a lot out there. But out of the 15 or 20 people that raised their hands, that this may be a solution that can get you kind of like that good enough experience. Like, well, I can use the thing that I'm not even using at all, or we use them in an island and they can just call room to room. Now you can schedule meetings with Skype for Business server, go into those rooms and call into those meetings and have audio and video be part of them. If you want content, you could do out-of-band content. You could be like, well, I got my laptop, so I'll just share, I'll connect to the meeting and make sure I don't do the audio and hang that up so I don't have an audio loop in the room, and then send that content that way. So it's more of that, there's a workable user experience that's provided free in the product. Or what if you need, look, I need bidirectional content sharing with federated, I need the whole thing, I need all those solutions, and I have a model that I have some of those pieces, or I don't have any of those Tandberg or Cisco telepresence systems, I've got different systems, or for whatever reason you can't utilize the Viz model today. Then like I said, you can go down to the expo floor and there's demonstrations down there of, okay, third-party systems that go above and beyond the free built-in capability to unlock those room systems and just continue to use your desktop Skype for Business application and make that your conferencing solution and not leave the standards-based systems off to the side. So 19 seconds behind schedule. I did a pretty good job on that one. Thank you. So that leaves us about 10 minutes for any Q&A. If anybody has questions as you're speaking, could you do me a favor and raise your hand, because I'm just going to see a bunch of faces at mics and not actually be able to tell who's speaking. So mic should be on. Go ahead.
Is it on? Okay.
Yep.
You mentioned that the Skype and Skype for Business clients cannot have conference calls together, right? With several people participating on the Skype side.
With the consumer client, you mean?
Yes, the consumer client, yes.
Yeah, so you can do peer-to-peer video calls between Skype for Business and Skype Consumer, but the consumer clients don't yet have the ability to join a conference call and get in that multi-party call and do any of that stuff. That's stuff that Microsoft is still talking about, what the roadmap for that might be.
So when I'm doing a conference call with Skype for Business, I could add only one consumer client at that point, or none at all.
I'm sorry, I didn't quite catch that.
If I do a conference call within the Skype for Business environment,
yep.
I could only add one consumer client, or none at all.
Yeah, you can't. That consumer client can't even talk to the call at all. Okay. So it's only one user on Skype for Business to one Skype consumer client.
All right, and just a short one. When can I migrate my contacts from Skype to Skype for Business clients?
So one of the things, and there was a session, I don't know if it already happened or is coming up, where they talk about the Skype search, the directory capabilities. So that with the Skype for Business front-end server and the edge server in your environment, you can unlock some of the Skype search, so you can now find these other contacts. And then I believe one of the slides has a table that shows which different modalities are supported in those peer two-party calls.
Okay, thanks.
Welcome.
Can we co-locate this role with another server? Can this role be co-located with another server, like mediation server?
The Viz role? No, the Viz can't be co-located on the front end or mediation. It has to be a separate server. Okay. And really, you wouldn't want to do that because the cost of transcoding video is high.
Okay, thanks.
Yep.
If you mentioned that you can't call a Viz connected system from the PSTN, but if you have a conference going and a PSTN caller calls into that conference, can he hear the room system and can the room system hear him?
Yeah. So basically, if you, from the VTC, join a call, because you can call the front-end server, and then there's audio participants that are also on that same, yeah, you can all hear that. You just can't make a two-party call. I can't just, from a conference room, call someone's phone.
Great, thanks.
Yep.
I'll prefix my question that I'm not a Link for Mac user, but what about Link for Mac?
No. Sorry, I was trying to find.
Yeah,
it's so blurry up here.
I'm not a Link for Mac user, but I support them. What about Link for Mac?
So I think it was today Microsoft announced in one session that the end of the year there'll be a new Link for Mac client. I don't know what they said in terms of what the capabilities will be, but if it supports these audio and video codecs and it's part of the Skype for Business family, it should slot into the same sort of calling capabilities here. I mean, they're not going to build a new client and put real-time video in as the video codec. So.
But their current version, do you know?
Oh, the 2010 or the 2011 client? I think it was specifically let off the supported client list, so probably not. I'd have to go back and check that.
That's what I thought. Okay, good, thanks.
Okay, here.
Man, I can't see anything. There we go. Okay, go ahead.
So before Microsoft announced that Viz server, the solution was there's something called a VCS gateway. So with the VIS, we don't need to deploy the VCS gateway anymore, right? We just need to make sure the COCM manager is 10.1. Do we still need that gateway?
Yeah, 10.5. Yeah, that's the supported platform.
But do we still need the VCS gateway? Do you know about that?
VCS, sorry. Yeah, so if you look at TechNet, there's actually, which I find funny they put it in there, there's a little asterisk next to that says there's one TAP customer, which is the Technology Adoption Program, so select customers of Microsoft that have basically been running Skype for Business for months, their early beta. There's a note, and it might vanish after I've pointed it out, that it says one TAP customer has successfully paired a VCS gateway with Viz, but it goes on to say it's totally unsupported and untested by Microsoft.
So it's not required to have that, the VCS?
Correct. It would be, the supported topology is that the VTC has to be registered, SIP registered to CUCM, which is then trumped.
Now the question is, you mentioned we need to have that Skype for Business server to use the VIS.
Yes.
Server. So can I deploy another Skype for Business server as another pool that coexistence with the Link 2013 server?
Yes.
Okay.
Yeah, all you need is a Skype for Business front-end pool deployed and set as the next hop. You can leave all your users on Link and have all them do video calls and conference calls, and the VTCs can get into it.
Okay, so I don't need to upgrade my 2013.
Correct.
Okay, great, thank you.
Yep.
How about call admission control? Is Viz CAC aware?
I would probably just guess no, because I saw that nowhere in the documentation.
Okay.
Maybe, who knows, but initially no. So like QoE and QoS and all that, it's kind of like falling off a cliff. You're not going to see what's on the other side of that. You're just going to shoot some video out and get some video and audio back in.
Okay.
Right here.
Are the Skype for server bits available? I was just looking, it still shows it as link server, so like if I wanted to put it in a lab environment.
It hit the MSDN portal on Friday, I believe. So if you've got a license to go to MSDN and download them, then they're available, but they're RTM. They're final.
Skype for Business 2015.
Yeah, Skype for Business 2015 server. It's a single ISO you can download and install from.
And your CALs or your link CALs for 2013, are they the same, or do you have?
I will politely decline any Microsoft licensing questions, because you can only get yourself in trouble with those. But there's plenty of guys downstairs in blue shirts you can ask.
Excuse me.
Yep.
You said that one server with the correct resources should be able to handle 16 sessions. So it's 16
streams, and this is based on testing Microsoft did, saying this size box, when we get above 16 streams, it just kind of doesn't, it isn't good.
Dual-way streams.
Yeah, so that could be 16 VTCs without the enhanced option open, or with the enhanced option, it could be less than 16, because you don't know if there could be 2 or 3 or 4 additional streams for that one system. It just depends on how complex the meeting they're joining is in terms of different requests.
But there will also be a media stream going the other way to the VTC.
Yes. Oh, you're talking about, is it 8 VTCs with...
Yeah.
It just said 16 streams, so I'd have to actually ask someone if they assumed bidirectional or if they mean 16 individual single direction streams. So that's a good question.
Okay.
I'll see if I can find out. I'll tweet the answer if somebody knows it.
Awesome. Thanks.
Welcome. Anyone else? Okay.
So when VTC joins a meeting that has, let's say, 5...
Sorry, I can't quite hear you.
When VTC joins a meeting that has, let's say, 5 participants, what is it going to see? Is it going to see 5 screens?
No, it's just going to see one active speaker. It's just going to receive one stream. Because the VTC can't support gallery or SVC, which provides multiple streams.
Okay.
So they're just going to see one person up on the monitor.
And when you say that the VIS transcodes, what do you mean by transcoding in this case? Since it only sends one stream, what is the transcoding?
What is I'm sorry, the what?
Transcoding on the VIS, what does it actually mean?
It's transcoding that one stream from SVC to AVC and then back.
So it means strips the layers. Stripping the
it doesn't even do anything necessarily with the layers, because the layering is part of SVC. All that needs to go away. AVC doesn't support layers. So it's kind of like the apples to oranges. It's completely changing it.
Thank you.
Yep. Okay, over here.
Just a quick verification. So a traditional VTC room could dial into a Skype conference video call, but can a link client join into a VTC bridge call, like an accordion bridge?
No. So this is all about bringing for multiple reasons. One, accordion bridges live off the VCS infrastructure, and you have to take the Cisco system and not register it to VCS, but register it to CUCM and send it over. So this is really intended for when you don't have those infrastructures or you don't want them. It's like you just got a bunch of room systems and you want to have them kind of be part of it.
So that's not even a future thing. It's just
Correct. Yeah. Yeah. Not only can Link not call into the VTC, it couldn't even call into the Codian. Codians don't even support any of the Link protocols.
Okay. Thank you.
Anyone right here? Okay.
So right now we actually have the VCS, and it's set up as a trusted application pool.
Yep.
And we have a separate SIP domain for the video devices. So the users are used to kind of going that way, but with this, we have to change to a phone number base.
Yeah, it's totally different approach than because what you're used to is this back-to-back user agent approach of the VTC has presence. Yeah.
Okay.
And the main thing is what you have can only do peer calls. You can't get into the AVMCU.
Yeah, and it's not very consistent. Yeah. Okay.
Yep.
All right. Thanks.
Over
here. Anyone else?
Right here, right here.
Wow, I can't even. Wow, you're right under the spotlight. Okay.
So I just want to make sure I understand this. Video-enabled IP phones now, whereas before, like with CUCM, would offer a video SDP, but the mediation server would ignore it. If that's now that same call through the Viz server will establish video with a link client.
So those phones are not on the list of supported systems. So I don't know if they're not there because they haven't tested them or they're not there because that doesn't work yet.
Okay.
I would think that if the phone is registered, basically call manager would have to know to send that call through the video trunk and not the audio trunk.
Yeah, so my point would be is that I would get rid of the mediation server in this case and point all link-related calls towards the Viz server. In hopes that I would establish a video call. Because now the SD.
Yeah, I don't know. I mean, you'd lose FEC and you'd lose encryption and yeah, I don't know if I see where you're going, but I would think that based on the limited capability of Viz as is, you'd probably lose more than you would gain. But there could be potentially a roadmap of, okay, I just want to use the video trunking component and I could send video and or audio calls.
Yeah. Okay.
Anyone? Just go ahead and start speaking and then raise your hand, I'll find you. Okay.
Just a question. I noticed that these slides were not available or not there.
Oh yeah, the sessions, I haven't even attended a session myself, so I don't know how quickly they've been posting them, but has it been like the next day or are they even online yet? Oh, it's 48 hours, so within a couple days they'll post the session and the recording.
Okay, thank you.
Welcome.
I have a question regarding to the virtualization. I'm not sure. Does Microsoft update the story for virtualization? Like say, what is for Viz? Does it support for virtualization or overall Skype for Business too?
I didn't see. I don't know. I haven't looked at that yet.
Okay, yeah.
Who's next? Anybody? Okay, if that's the last question, then thanks for coming.